So for this problem, we're asked to use superposition to determine Ix, which is the current here. So the first thing that we're going to do is we're going to figure out the contribution to the Ix through the 4 amp source. Okay, so we're going to redraw this circuit without the 48 volt source, and instead we are going to replace it by a short circuit. Okay, so now we have 2, 4, 6, 4 amps, 3, 2. So now again, we want to figure out, this will be Ix prime. And you can use whatever method you want. I'm going to use mesh analysis. So we'll call this I1, this I2, and this I3. And of course, I3 is going to be negative 4 amps because it is the only current going through this branch here. Okay, so now we want to figure out the mesh equation for that I1, and that's going to be 2I1 plus 3 times I1 minus I3 plus 2I1 minus I2 equals 0. Okay, so we can group our like terms, and we'll have 7I1 minus 2I2 minus 3I3 is equal to 0. And again, we can replace that I3, so we have 7I1 minus 2I2 is going to be equal to 3 times negative 4, which is equal to negative 12. So that's our first equation. So now we need to do our second mesh, which is mesh I2. And so that will be 2I2 minus I1 plus 6I2 minus I3 plus 4I2 equals 0. Okay, we can again put our like terms together, and that will be minus 2I1 plus 12I2 will equal 6I3, and that will be 6 times negative 4, which is equal to negative 24. So now we have two equations and two unknowns, so we will solve. So we have 7I1 minus 2I2 equals negative 12, and negative 2I1 plus 12I2 equals negative 24. And from this, we will get I1 is equal to negative 2.4 amps, and I2 is equal to negative 2.4 amps. All right, but we're looking for Ix. So if we look again at the circuit, okay, we had this. And we had I2 here, I3 there, which was the 4 amps. And so at this node here, we have I3 coming in, we have I2 coming out, and we have Ix coming in. So the KCL at that node is going to be minus Ix minus I3 plus I2 is 0. So Ix is going to be I2 minus I3, which means negative 2.4 minus a negative 4 amps. So our answer there is going to be 1.6 amps. So that is Ix when we have the contribution only from that 4 amp source. Now the next thing that we need to do is to figure out the contribution when we open circuit that 4 amp source, and we only look at IX that is contributed by that 48 volt source. So 2 ohms, 3 ohms, 2 ohms, 48 volts. This will be 6 ohms and 4 ohms. So that's the new picture that we draw. Again, that 4 amp is set to 0, and that means it will be an open circuit. So now we have IX double prime here, and we need to figure it out. So this time I'm going to use NVM with this node here, and I'll make this the reference node. Okay, so we're going to do KCL at node V. Okay, so that will be V over 5 plus V minus 48 over 2 plus V over 10 equal to 0. Let's multiply that out times 10. So we'll have 2V plus 5 times V minus 48 plus V equal to 0. We'll combine our like terms, and that will be 8V is equal to 240. So V will be equal to 30 volts. And we want IX double prime, and that's going to be equal to V over 10. So that will be 3 amps. Okay, so now we have the contributions from the 4 amp source, which was IX prime equals 1.6 amps, and the contributions from the 48 volt source, which was 3 amps. So we want to add those together to get the total IX, so that will be 4.6 amps. Okay.